Hello and welcome back for Chapter 6, Lesson 1. We're talking about integer exponents. So let's talk about just that name, right? The name of this title, integer. Well, what are integers? Remember, those are positive and negative whole numbers. So something like -4, -3, -2, -1, 0, 1, 2, 3. Okay, so those, and it goes in both directions, on both sides, right? It just keeps going in the negative direction and keep going in the positive direction. Those are integers. Now the integers are going to be exponents, right? So remember what an exponent is. That's something where you have, like 4 squared. That little number up there, that's called the exponent. So this is about having integers in the exponents. So having positive numbers in the exponents, which is probably what we're used to, having 0 in the exponent, and also having negative numbers in the exponent. So the objectives for today are to evaluate expressions containing 0 and integer exponents. We're also going to simplify expressions containing 0 and integer exponents. All right, let's go ahead and get started. So just to remember exponents, just a little terminology. This little number right here, that is the exponent. It's the little number, it's raised up. And then the x would be considered the base. Okay, so that's the base of the number, and that's the exponent. And x to the 4th, do you remember what that means? X to the 4th is the base of x, and the exponent of 4, that is the same thing. It's almost kind of like a shortcut. So it's a shorter version than writing x times x times x times x. Those two things mean the same thing, right? So if we had something like x cubed, that would be the same thing as x times x times x, right? And the same thing is true for numbers. If we had 5, to the 6th power, that's the same thing as 5 times 5 times 5 times 5 times 5. That's 1, 2, 3, 4, 5 times 6. Times 5, but it's 6 times. 5 multiplied by itself 6 times. So 1, 2, 3, 4, 5, 6. Okay? Right, so those are exponents. Those are what exponents means, and then you could actually figure out what the number. It's just a really big number. So exponents help you write really, really big numbers, and they also become like way convenient. Instead of writing like 2 to the 100th power, like what would that be? 2 times 2 times 2, and it would be like 100 2s, right? Nobody wants to write that. It's way easier to write just 2 to the 100th power, right? Because they mean the same thing. 2 to the 100th is just a really big number. So what is this about? This is about having integers in the exponent. So we know what happens when there's a positive, right? All these are positive integers. But we're going to look at what happens when there's a 0 in the exponent. What happens when there's a negative number in the exponent? Okay, so let's just go ahead and explore this a bit further. So like I previously said, you have seen positive exponents. Recall that to simplify 3 squared, use 3 as a factor 2 times. So 3 squared is the same thing as 3 times 3, which is equal to 9, okay? But what does it mean for an exponent to be negative or to be 0? So let's go ahead and look at this table. So 5 squared, what it's saying, 5 squared is 3,125, right? And what is 5? Did I say 5 squared? I meant 5 to the 5th power. I'm sorry. This is 5 to the 5th power. That means if we go 5 times 5 times 5 times 5 times 5, 1, 2, 3, 4, 5 times, we would get that number. Let's go ahead and see if that's true. Is this turning on? Come on, baby. There we go. Clear that out. So 5 times, can you see it? 5, which is 25, right? That's 2 times 5, that's 3 times 5, that's 4 times 5, that would be 5. And what does it end up with? Yes, 3,125. Okay? So 5 to the 4th, which would be just 5 times 5 times 5 times 5, is actually 625. 5 to the 3rd power, 5 times 5 times 5 is 125. 5 squared is 25, and 5 to the 1st power is 5, okay? So what is this saying? Okay, so we know what 5 to the 5th, 5 to the 4th, 5 to the 3rd, 5 squared, and 5 to the 1st power are. But what's happening between here? Well, when we have 5 to the 5th power, right, which is 5 times 5 times 5 times 5 times 5, and we divide that by 5, what happens? The 5 divided by 5, that ends up being 1, right? That it cancels out being 1, and what are we left with? We're left with 5 to the 4th power, right? 1, 2, 3, 4. Does that make sense? Which is 625. But what happens when we have 5 to the 4th power? Well, what is that? Well, that's 5 to the 4th power is the same thing as 5 times 5 times 5 times 5, right? And then we divide that by 5, right? What happens? Well, 5 divided by 5 divided by 5 is 1. And what are we left with? 5 times 5 times 5, which is 5 to the 3rd power. So when we divide by 5, 5 to the 4th, divided by 5, we end up with 5 to the 3rd. Well, what happens when we take 5 to the 3rd and divide it by 5? Right? So if we have 5 to the 3rd, 5 times 5 times 5, and then we divide that by 5, what happens? Well, we end up with 5 divided by 5, right? And well, that 5 divided by 5 is 1, and so we're left with 5 times 5, which is 5 squared, right? Which is 25. Well, what happens when we take 25 and divide it by 5? Well, 25 is 5 squared is the same thing as 5 times 5, right? Well, what happens when we divide that by 5? What do we have here? 5 divided by 5. 5 divided by 5 is 1, which means that's why we're left with 5, or 5 to the 1st power. But what happens when we divide 5 by 5 to the 1st power divided by 5? So when we take 5 to the 1st power and we divide that by 5, what do we end up with? We end up with 1. And that's why if you take 5 to the 1st power and you divide it by 5 again, you end up with 1, which means 5 to the 0th power is equal to 1. Well, if we divide this by 5 again, right, if you look at these exponents, what's happening? 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. So if I went 0 minus 1, right, and what's the pattern? We're dividing each thing by 5 and the exponent's going down by 1. So if we can keep dividing by 5, right, 1 minus 1 is 0. 0 minus 1 is going to give us negative 1. So if we take this 1 and we divide it by 5, what happens? If we take 1 and divide it by 5, we end up with 1/5. So 5 to the negative 1 power is actually the same thing as 1/5. Well, what happens if we take that and divide it by 5? What do we get? So if we take this right here, this 1/5, right? I'm going to take 1/5 and I'm going to divide it by 5, right? Which is the same thing as 1/5 divided by 5. I'm going old school, right? Which is the same thing as 1/5 times the reciprocal, which is 1/5, which is the same thing as 1 over 5 times 5, which is 5 squared. And look at that. So that means this is the same thing as 1/5 squared. And look at that. That's 5 squared with the negative, but now 5 squared is in the bottom, which is the same thing as 5 times 5, which is 1/25. It's 1/25, but I want you to see this relationship that this negative is actually when it goes to the bottom, it becomes positive, 1 over 5 squared. Let's say we took this out one more time. Can anybody guess what it's going to be? Let's say we go 5 to the negative 3, and we divide it by 5 again, right? Okay, so I'm going to take 5 squared, which is the same thing as 5 times 5, and we're going to divide it by 5 again, right? Which is the same thing as 5 times 5 divided by 5, which is the same thing as multiplying by the reciprocal, right? Which would be 1/5, which means we end up with 1 over 5 times 5 times 5, which is 5 to the 3rd power. Look at that. 1 over 5 to the 3rd power. Notice how it's 5 to the negative 3 is the same thing as 1 over 5 to the 3rd power, which is just 1 over 5 times 5, which is 25 times 5 is 125. Look at that. Isn't that interesting? As you continue to divide by 5, that same base, this, right, 5 to the negative 1 becomes 5 to the 1st power, 5 to the negative 2 becomes 5 to the 2nd power, 5 to the negative 3 becomes 1 over 5 to the 3rd power, 1 divided by 5 to the 3rd power. Isn't that interesting, the relationship with the negative exponents? So this leads us into some general rules. Okay, so there's two kind of rules, theorems here. So the first one is dealing with that 0 in the exponent. 5 to the 0, well, we said it's 1, and that's really just 0 exponents are any non-zero number, so it can't be 0, it's just anything besides 0, raised to the 0 power is 1. That is the rule that you always have to remember. So 3 to the 0 power, what does it equal to? 1. You know, 123 to the 0 power, what does it equal to? 1. What about a negative number? Negative, the quantity, see how it's in parentheses? That means whatever is in the parentheses is raised to the 0 power. It doesn't matter what's in those parentheses. Everything in there. You could have like a million different things. As long as they're all in parentheses and raised to the 0 power, guess what it is? It's equal to 1. Here, we have some more stuff inside the parentheses. We have a division, 3 divided by 7, or 3/7 to the 0 power. That is equal to 1. Right there. Okay, so it doesn't matter what's inside those parentheses. You could almost just ignore it. Whenever you see a bunch of stuff in parentheses, as long as all that stuff's raised to the 0 power, you know the answer is 1, okay? So if is not equal to 0, okay, so x cannot equal 0, then this is the rule right here. X to the 0 power, anything to the 0 power is always 1, okay? So you have to memorize that rule, okay? The second is about negative exponents. So you know what happens with positive exponents, and now you know anything raised to the 0 power is 1. But let's talk about the negative exponents. So with a negative exponent, what it states is the negative exponents, a non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite positive exponent. So let's see here. So 3, right, to the negative 2 is the same thing as equal to 1 divided by that. Okay, so if you see here, it's negative here, and then it kind of just flips to the bottom. It swaps. It's in the top of the bottom, so it's like a fraction, right? You got two sides to the fraction. You got the top and you got the bottom. So it's in the top, it's negative, so it can just swap down to the bottom. It's 3 to the negative 2. It becomes positive, 3 squared, 1 divided by 3 squared, which is the same thing as 1 over 3 times 3, which is 9. So the answer ends up being 1/9, okay? And the same is true for this right here. 2 to the negative 4, you see that negative? Well, that's fine. That's okay. That's the same thing as 1 divided by 2 to the positive 4, and that which equals 1 divided by 2 times 2 times 2 times 2. right? So this is 1 divided by 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So boom. There you have it. So it says, if x is not equal to 0 and n is an integer, then x to the negative n power is equal to 1 over the same thing, but now n is positive. All right, so let's look at an example. So here, example 1, we're looking at this application. So it says 1 cup is 2 to the negative 4th gallon. We need to simplify this expression. Whenever you see simplify the expression, you can think about that as get rid of the negative exponents. Okay? So we have 2 to the negative 4th. Well, what do we know with our rule here? We know that's the same thing as 1 divided by 2 to the 4th power, right? Which is the same thing as 1 over 2 times 2 times 2 times 2, which equals 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 1/16, that is simplified. There's no longer a negative number, and we figured out what that number is. Perfect. Okay, on to the next problem. It says a sandfly may have a wingspan of up to 5 to the negative 3 meters. Simplify this expression. We can do it. So we have 5 to the negative 3rd power. Remember, whenever we see that negative exponent, that means 1 divided by the same thing, but now it's 5 to the 3rd power, and 3 is positive. This means 1 times 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. And that's how you simplify that expression. Perfect. That's it for example 1. I'll see you in a little bit for example 2.